Hi everyone, this is Kushal Shishmali and thank you for visiting our YouTube channel. In this YouTube video, we are going to talk about the proposals that were about adding Lambda functions to the C++ standard. And do remember that they were introduced in C++11. Before that, there were no such Lambda functions in the C++ standard. There might be some third-party libraries which introduced that, but in the C++ standard, it was not there. And these are the proposals that were trying to convince the whole community and the whole lot of developers, whoever decides this, right? Hey, please add Lambda functions. Now, it's really important that we talk about these proposals because it kind of, sets the story and sets the plot that what was the motivation, why was it required, and what is the implementation, like how should the structure of a Lambda function look like, not the particular implementation towards the compiler side, but how it should look like, right? So these are really important points that are covered in these proposals, and that's why I wanted to talk about it. And these, so the very first proposal I'm going to talk about is titled A Proposal to Add Lambda Functions to the C++ Standard, right? Just a few things to take note of, like whatever points I'll be trying to make, I'll be underlining them along with the highlighted content over here. So please follow me along and don't try to read the whole 16 pages right in this YouTube video, because anyways I'm not going to cover all of that. The second thing is the links to links to all the proposals will be down below in the description, so you can always go back and read all the documents once this YouTube video is finished, right? So let's dive right in. It's written by Valentin Samko. Full credits to him. I apologize if I'm not pronounced it right, but the author, I'll refer to him as the author, right? This was published on 23rd of February 2006. That's great, right? It starts with a very important point. C++ has a concept of function objects which are the first class values, right? And this is a really important point. Let me underline this for you, right? Now, what are the what are the function objects? Function objects are nothing but those types which have the call operator overloaded, okay? And what are the first class values? Which can be passed as arguments, returned from a function, bound to variable names, and they can be used just like an integer or string type is used, right? So here they have mentioned it here as well, right? Which can be passed as arguments, returned from function calls, bound to variable names, just like simpler types such as strings and integers, right? Now, let's go down and talk about the motivation. It's really important what I have underlined here. C++ standard library algorithms would be much more pleasant to use if C++ had support for lambdas. Now, it's important because C++ standard library algorithms has a lot of useful algorithms. For example, they have sort function, they have swap function, they have for each, they have transform, they have so many functions, like so many algorithms implemented, right? And even I don't use them. Like, think about me in 2006, right? I don't use them right now because they require me to define a whole set of, like, a whole class and with an operator overloaded just for a single call where I need to pass a function object, right? Just imagine that you want to sort a vector, right? Then what will you have to do? You will have to call sort function with a begin iterator, end iterator, and a function object. Now that function object needs to be defined in some other scope. At least I have to go out of the current function and define that, give it a name and all of those things. But my problem is I'm only going to call it once in my whole set of code, whatever I have. And it doesn't make sense. Like, it's really difficult for developers to have this syntactic overhead, and that is what they talk about here. You see, many developers do not use function objects simply because of the syntactic overhead. And by syntactic overhead, it just means that for the whole syntax of the code, it just gives it a overhead that there is this function that you have to look at while debugging, while reading the code. It's just a lot of code, right? And that's why. Now let's go dive right into the third comment. They introduce a very complicated and unreadable syntax, also leading to code which is very hard to debug or analyze crash terms. And by the way, this is about boost.lambda or boost.bind, standard C++ library binders. These were present in the boost library before C++11 as well. That means the lambda functions were implemented in third-party libraries, but they were really complicated, right? And probably unreadable syntax as well for those developers who are just starting with. May not be for all, but still not that convenient for any developer to use these algorithms and debug. Like imagine yourself having a third-party library in a code and you having a segmentation fault or any crash dump, and you're trying to analyze what went wrong, and then like suddenly, okay, this is a problem with the third-party library. Then you have to go back and understand from their issues what the solution can be. So it will be great if stored library algorithms will not depend on a third-party library for the ease of development and readability purpose, right? Now, another problem that they mention is when one compiles source code which uses these libraries having inlining disabled, the performance is often severely affected. That just means that if you have inline in the code, like for example, the functions disabled, that means the compiler cannot automatically replace the calls with the definition and all, right? Now, the performance is often severely affected because of having a third-party library that they have to compile and all, which makes sense, right? If you go down, it says most users will not use algorithms which require functional objects as long as one has to write more code to construct such function objects than one would write to embed that algorithm into their code, right? Now, think of what the author has done. They have given some 4 examples that I'm going to show you right now. They have tried to solve a problem statement that is not in the scope of this video, but they are trying to suggest that there are 4 methods that this can be solved right now, including the proposed lambda functions. And you decide which one is easier. Okay, I'm gonna let you decide that, and let's see. The very first is a lambda function that they are proposing, right? They have a function called foo, and here they are taking some vector my set int a. Okay, that is okay. Now they're calling v.arrays and stood remove if function, where it takes a begin iterator, end iterator, and a lambda function. So this is, by the way, this is the whole lambda function that they have proposed, the way it should look like, and that is it. That's what they're suggesting here. And if you go down, there's a custom predicate which takes a struct and it overloads the operator, right? As you can see, this is having an overloaded operator, right? And this is defined, it's doing something, then they have some variables stored in the private scope, and then they're calling it here stored remove if, the same thing, but here they are calling the my predicate, right? This is the function object, by the way, my predicate s comma a, right? And that is one way it could be done. And the third is the custom code instead of the standard algorithm. Now this totally removes the stored algorithm. Here you can see that there is no stored remove if. That means they have just defined it their own algorithm to use, and this is also fine as long as the number of lines of code is concerned. This is fine, but for performance basis and all, stored library algorithms may be more optimized. And why would someone have a custom algorithm, right? And just think about it. If you have a function in the stored library, why not use it? And there's this third-party library for tr1 bind, which does it for you. I'm not going to go into this because it already looks complex and really hard to read for now, unless until you are familiar with the third-party library. Now you decide which one is the best way. And I do feel that for this purpose, I agree that lambda function is like very easy to read, very easy to debug as well, probably because you know that you're only having this function here. So whatever that is going wrong in the line, you just need to take a look at this line and figure out what's going wrong. And this makes sense. But second and third is also fine. Third, I will say that having a custom code instead of the standard algorithm is not what I personally would prefer. And custom predicate is fine if you want to do a lot of things and you want to reuse it. But I don't feel that for this particular code, you need to reuse that. So I will say that if one was there, I would definitely use it. And I hope that we're on the same page here. So if you go down, it says option 1 would be the most simple and brief as seen from this example, which is true, right? And that's what they're trying to say. Now let's talk about the required functionality. One of the very important points they mention is Lambda must be significantly easier to read, write, and debug than any possible library solutions, right? And it's important because if the Lambda, whatever the proposal is, it's not easier to read, write, and debug, then there's no sense, because the very important part of Lambda, having Lambda functions, is to trying to reduce the syntactic overhead apart from all its other required functionalities. This is really important. So that's why it should be really easy to use and read. Now there are a lot of definitions which are covered in the different proposals. So I'm going to skip it for now and just that is it. Like you can scroll down, there's a lot of stuff going on in this proposal, but I'm just going to skip all of that and go directly to the next proposal, which is going to cover a lot of things. Yes, now we're in the second proposal where they are talking about lambda expressions and closures for C++. It is dated 26th of February 2006 and it is written by the 5 authors listed here. Now this proposal is really important because it defines lambda expression and lambda functions and closures beautifully, right? So I'll just be covering those definitions and we'll skip the motivation part because we've already covered that in the previous proposal. The very first thing, lambda expression and lambda functions are used interchangeably. So never get yourself confused that when someone says lambda expression and the other person says lambda function. A lambda expression is an expression that specifies an anonymous function object. That means you don't really need to bind it to a variable name, right? Whatever function object you are creating, it can be anonymous, right? It can be in that place wherever you're calling that. Okay, it's also called in place, but don't get yourself confused with the in place specifier type for functions, right? And a closure is what? It's an anonymous function object that is created automatically by the compiler as a result of the lambda expression, right? What compiler does is whenever it sees a lambda expression, it generates a whole anonymous function object, which is kind of a class and all with an overloaded operator or an implemented operator, call operator, right? And a closure stores those variables from the scope of the definition of the lambda expression that are used in the lambda expression. That just means here, if you kind of scroll down, you will see a struct, right, with a operator, call operator implemented. With what it says is it, just do this thing for me, and they have this int I here. That means they have stored those variables somehow in the scope, and that's what an anonymous function object will also have, referring to a closure here. That means they will have the variables stored in a scope which are used in the lambda expression, right? That means in addition to its own function parameters, a lambda expression can refer to local variables in the scope of its definition. So for example, whenever you're using a lambda function, you have some variables stored like just in that scope above, for example, int x comma y. Now you want to use them in the lambda expression. You don't want to really call them through the parameter list. That's something you can do as well, and that's what lambda function allows you to do, right? Even though handwritten function objects can be used in place of the proposed closures, the direct definition and construction of function objects is cumbersome. That just means that even though there is a possibility that you can just follow the function objects, whatever they used to use before this, but that is really cumbersome. That takes up a lot of space and all. And to define a function object, an entire class must be defined, in many cases including member variables and a constructor to initialize them, right? Because if you're using some local variables in the scope of its definition, then you need to have member variables and a constructor, because you will need to initialize them as well. Furthermore, the class must be named prior to its use and defined outside of the function that uses it. This is really important, right? By the time, I mean, it clearly says that unless proposal to allow local classes as template arguments is approved, right? So the very first thing is the class must be named prior to its use. That means you need to have a name for that. You cannot have it anonymous, and this is really a burden for a lot of people, because if they're calling it just once, they want to have it there. They don't really want to have a name for that. For some people it's really difficult to name them, right? And for me it is definitely there. And define outside of the function that uses it. And this also breaks a really important rule of C++, that whenever you're using it for the very first time, you should have that declaration as close as possible, if this is really possible according to your design, but it will be great. So just ignore that, right? So this will be really great, and that's what they are suggesting here, that why it's a problem. Now here they clearly mention that lambda expressions described in this proposal are syntactic sugar for defining function object classes such as the above, which you can see here, the struct less than I, and constructing function objects from them using the context of local variables, right? You can see that they have some local variable int I is equal to 17, and they're using it here. They're passing it here as a parameter, right? And they have a constructor for that, and then they have this overloaded operator, call operator here, and that is it. That's what they are doing here, right? And according to them, a motivation is from the above code you see. As an example, consider the above call to find if function. The definition of the function object is so verbose that it would be much easier and likely clearer to readers of the code to write a for loop to iterate through a sequence than to define a new function object type, construct an object using the correct arguments, and then call find if. And this is really important if you understand from the previous proposal as well. What what the authors are trying to say is that it will be easier to just have a for loop instead of defining a struct and having an operator overloaded and then having a constructor and storing them as member variables. But what that does is it stops you from using the std library algorithms, like whatever they have implemented, and that is not good for the whole C++ community because those have been defined for a reason. That is why they are proposing Lambda functions, and you can always go down and see what they are proposing and all, but that is again we're going to discuss in the next proposal. So this is it for the second proposal. Now let's go to the third proposal. Right, so now we're on the last proposal that kind of revises the whole syntax they had proposed for the Lambda functions and throws a more light on the closures, right? It is titled Lambda Expressions and Closures, Wording for Monomorphic Lambdas. It's written by these three authors mentioned here. It was published in 2007, right? So let's just go dive right into the introduction. And here it clearly states that there are small changes in the proposed syntax, and do note that it is providing wording for monomorphic, that means non-generic Lambda functions, which they also touch upon down below what they actually mean by monomorphic Lambda functions, and I would love to discuss that in this YouTube video. Right, so let's go now to the in a nutshell, right, where they have mentioned a whole use case of using again the find if function that they have also mentioned in the previous proposal, but now it's different. They're saying that we want to find the first employee within a given salary range. That's the problem statement here. Now they are having this class, right, class between and they have these member variables low and high. In the public namespace they have the constructor which initializes low and high from the given parameters, right, and they have this operator called operator implemented with just taking the copy of the class, I think constant employee probably by reference, and just comparing whether the salary is getting equal to low and less than high, whether it is between the given range or not, right? And then they have the std find if function. And as you can already see, the syntactic requirement of defining a class with its member variables, function call operator and constructor, and then constructing an object of that type is very verbose, right? Here you can see that they are passing a function object by creating a object of this class, right? And it's not well suited for creating function objects on the fly to be used only once. And this is really important that, first of all, you're creating on the fly, calling it immediately as a third argument, right? And if you're using it only once, then it doesn't make sense. So we define the semantics of the Lambda expressions via translation to function objects, right? So anyways, that they are kind of defining the whole semantics of Lambda expressions by first understanding how they will translate to a function object, and that's how they're understanding the whole Lambda function proposal. With the proposed features, the above example becomes now like they are capturing everything by reference, and they are passing the parameter list as constant employee %e, and then they have this Lambda function implemented here. As you can see, the whole structure, I mean the class, is now converted to a simple one-line Lambda function, and this is really neat and clean. And for those who are who know what the Lambda functions are, this will be really easy to understand as well. And let's go down and talk about non-generic and generic Lambda functions. I've already mentioned that monomorphic Lambda functions are in the scope for this document, and they say that because the type of its parameters are explicitly specified. As you can see that they have specified constant employee %e for e they have defined the type, but if you were not to define the type, that will be a polymorphic version, and that this is not in the scope of this document because they had decided to focus on the monomorphic version of Lambda functions for now, right? And that is why, by the way, so polymorphic versions are called generic Lambda functions, and monomorphic Lambda functions will be called non-generic Lambda functions. Now the proposal, they clearly say that we demonstrate with a binary Lambda function that invokes operator plus on its argument. So this is just an example for Lambda functions with no external references. That means you're not trying to capture any local variable in that particular scope. You can see that they have this bracket kind of thing which just mentions that, hey, it's a Lambda function. They take two parameters, int x and int y, and return x plus y, right? And this is just a very simple Lambda function syntax that they were trying to suggest, and things have changed, by the way. Like you won't see this there first of all, and if you're trying to return something, you will see return statement written there, right? And they also mentioned that you can have a return type mentioned by using this, right? and they have mentioned in the proposal, which is by the way there, right? And that is it. If you will go down, they will also mention that how these Lambda functions are converted to an anonymous whole function object, right? And how they can be understood in terms of that function object. And they have just mentioned it here, what is hidden from the user, what is accessible to the user, and how is the operator overloaded or implemented with the constant type by default, right? That means you cannot modify them within this function body, though you can use them. Okay, that let's not go into that. You can have parameter types listed here, whatever p type, param1 and all. You can see that they are being passed here. So actually what this is trying to suggest is a Lambda function is nothing but a anonymous function object. Okay, and I cannot emphasize this enough, because as you can see, whatever Lambda function that is written here, it is translated to this anonymous function object, right? And this really helps you understand that Lambda functions are the syntactic sugar, right? They are trying to make it easy for everyone to use Lambda functions, for everyone to use the stored library algorithms. And this is it for this YouTube video, where we talked about the motivation, where we talked about all the proposals which I had in the list. I didn't go through the whole proposal because it's just too deep, and for everyone to understand this, they need the whole context of what's going on. But the motivation and what they're trying to suggest will definitely set the plot for the future videos, where we are definitely going to talk about Lambda expressions and what they do, the whole syntax of them, and how to use them. So that's something we are definitely going to touch upon. Don't worry about that. If you think this video was helpful, or if you like the content, please make sure to like the YouTube video. If you want to hear more from us, you can always subscribe to the YouTube channel of Melef42. That will help us a lot. If you have any suggestions, feedback, or any comments, please post them down in the comment section. You can always join the Discord channel if you want to have any conversation, any content ideas you have. We will be looking out for that. Thank you.